Okay, when we're talking about our transformations, we have two ideas that we're going to see that pop up a lot, and that's congruence and orientation. So first I want to talk about congruence. Congruence, before we can even start going, we have to know what that means. To be congruent means it's the same size and same shape. So what I have here is I have our four main transformations that we're going to be working with, and I want to talk about which ones are going to preserve congruence. So that means which one of these are going to keep the shape the same size and the exact same shape. First one we're looking at is our translations. Well, we have to know what a translation is. A translation is where we take a shape and then we slide it and we just move it to a new spot on the graph. That's all we're doing. We don't make it bigger, we don't make it smaller, we don't turn it. All we do is just slide it. So since we're not changing the size and since we're not alternating the shape, this translations are going to preserve our congruence. Then we have to know, let's look next at our rotations. Rotations, remember, are something where we take our shape and then we turn it, kind of like if you were going to turn it around a clock or turn it around on its axis. So I may start, let's see, with a triangle like this, and then when I rotate it, now I'm going to have a triangle like that, right? So I kind of rotated it down like this. But the question you have to ask yourself, did I change size? Did I change the shape? And the answer is no. With a rotation, all we do is take that shape and we turn it. We don't adjust the size. So does a rotation preserve congruence? Yeah, it does. Next one, let's look at reflections. Reflections, the biggest example is look at yourself in a mirror, right? Things kind of flip. It's there, but things are kind of a little bit backwards. So the way we like to draw it here is if I have a triangle going this way and I flip it, it's going to now be heading that way. Now, again, we ask ourselves, to preserve congruence, did it change the size? Did it change the shape? Well, ask yourself, if you look in a normal mirror, do you appear to get bigger or do you appear to get smaller when you look in that mirror? Probably not. So at that point, we're saying, well then, does our reflection preserve congruence? Does it change the size? Does it change the shape? Does it preserve congruence? Yes, it does. Because our reflection just flips it across the axis, doesn't change the size, doesn't change the shape. Last one we're going to look at is our dilations. Now dilations are when we're dilating things, making them either bigger or smaller. We have enlargements or reductions. That's what a dilation is. And remember, we kind of had that example of your pupils, right? They dilate them, they make them big so they can see inside. And if you notice, when you turn on the lights from being in a dark room, sometimes you can catch them shrinking. So in a dilation, we either have a small shape that turns into a bigger shape, or we have a bigger shape that turns into a smaller shape. So if it comes to the issue of congruence, we're asking ourselves, in a dilation, does the size and shape change? So, does a dilation preserve congruence? No. Because our size changes, that's the whole purpose of the dilation, it's not preserving the congruence because it's changing the size of the shape we're working with. So, I'm looking for things, what preserves congruence? Translations, rotations, and reflections will preserve congruence. They all keep the same size and shape. Our dilations is the one transformation that is not going to preserve congruence because it changes the size.